All right, so today we're talking about patterns, sequences, and series. The goal is to refresh your memory on this concept, and the best way to do this is honestly through examples. So you need your reference booklet, and if you don't remember the formulas, then of course grab your whiteboard materials. Because in all honesty, guys, arithmetic and geometric sequences series is like, which formula do you use? Figure that out. What variable are you looking for, and then plug in your numbers. There's also the binomial expansion things that we're also dealing with as well, but we'll get to that when we get there, okay? So this first one, find the 27th term of the arithmetic sequence for which U1 equals 29 and D equals 4. So you guys are working on this, right? You're done? Okay, then let me see your answer. Hold up. Okay. Very good. It looks like everyone recognized. I mean, it said it as well as arithmetic. You recognize that you needed the general formula of U sub n equals U1 plus n minus 1 times D. It doesn't tell you what everything means, but let's review it real quick. What does U sub n mean? It represents the nth term. In this particular case, that is what we're looking for. Okay? What does U1 represent? First term. This represents the first term. What does n represent? Number placement. And what does D represent? Difference. Your common difference, okay? It's different when you're looking at a geometric sequence. So yes, you guys plugged in 29 plus 27 minus 1 times 4, and the answer, I missed that. What was the answer? 133. Very good, okay? Whiteboard's cleared. Here's the next one. Find n for the arithmetic sequence in which U sub n is 96, U sub 1 is 42, and D is 6. Is 10. So you would have used the same formula, plugged in 96, 42, plus n minus 1 times 6. Okay? Now, real quick, I wish you guys didn't erase. Okay, let me tell you what to erase just because I want to see something else. So, well, then can you guys hold y'all up? Okay. I like.
Looking for Anna to pop.
No, I'm looking for something specific. Okay, here's. Yes, you do. Okay. Now the one thing. Okay. Now you guys, you can solve this however you want to because it is asking for n, but there's something that I do want to point out. Okay. If you distribute the 6 and then you combine like terms here and get what's that? 36 plus 6n. This right here is known as the explicit formula for this sequence. Okay. So if they ever ask you to write the explicit formula, they basically want the formula that I could use to plug in any term, to find any term. I could find the 10th term in the sequence using this formula, just by plugging in 10. Now, yes, granted, you could go back through and do this process all over again, but if it ever asks you for the explicit formula, it is what you get after you distribute the common difference over and then simplify. Sometimes they may give you this instead, like they may say, okay, U sub n is this, and then it says, what's the common difference? And they might give you this, and they ask you, what's the common difference?
GCF, right?
Huh?
The GCF?
No, not the GCF. It is whatever number's attached to your variable. This is your common difference. Now, you can always, of course, plug in 1, plug in 2, plug in 3, and look at the numbers in the sequence and determine the pattern there. But to save you some time, it's always the number that's attached to your variable. Okay? So do please keep that in mind. I don't want that to throw anybody off like, well, I didn't have the sequence in front of me. Yes, you do. Okay? What was n? 10. All right, clear your boards. Here's the next one. Don't clear it until I ask you to. Okay, here's the next one. This one is not accurate. First off, guys, you don't know your first term, you don't know your common difference, even to use the formula to find your 20th term, but do you guys remember that? Huh? You can shift everything over and temporarily make one of them your U1 term. You know, go about that method. Or do you guys remember doing this, where you subtract the terms and then subtract where they're placed? Okay, that's how you get negative 12 over negative 3. Your common difference is 4. Okay, you can do that. And then you can use one of your terms to find your first term. Negative 16 equals U sub 1 plus 16, and your first term was a negative 32. Okay? Is this coming back to you guys? okay, first term plus 20. And that term was it was 44. So the main one for this one was to refresh your memory about how to find the common difference when you're given two terms that aren't side by side. Okay. Questions on this? Okay. Now we're gonna find the explicit formula for this sequence. Go ahead and do that. Next up.
See for you.
Give it over.
I don't mind.
And that is your explicit formula. Okay? Explicit is basically a formula I can use to find any term. So if I ask you to find the 100th term of the sequence, all you have to do is
Plug in 100 in.
plug in 100. 100 times 3 plus 4 is 304. Here we go. Find the sum of the first 15 terms of the sequence. Find the sum of the first 15 terms of the sequence. Non-calculator for this one. 375, so let's take a look at it, okay? The formula for sum is n over 2 times, which formula would have been the easier one to use?
First one. Second one. I used the second one.
Second one's pretty easy. Okay, well let's take a look. Because I don't want to have to sit there and try to find my last term to do this. So it's 2 times your first term plus n minus 1 times d, right? Yes. D is what? 4. So I basically have 15 over 2, leave it as a fraction. I have negative 6 plus. So then I have 15 over 2 times 50. You guys, make it easier on yourself. How many times did 2 go into 50? So this is 15 times 25, which is 3.
So you can brush up on your multiplying as a decimal point. 7 times this is 25. Yeah, it's 25.
You multiply 50 by 15, then divide by 2.
All right, here's the next one. Yes, you can use your calculator.
Oh,
But do we have
Do you have to? No.
Okay.
I'll be very impressed.
Alright.
Find the 6th term of the geometric sequence. Remember the formula is u sub 1 times r to the n minus 1. U sub 1 represents what? First term. N represents your number of terms. So what is r?
1/3.
Your ratio. That is basically how is your sequence of proceeding. Is it decreasing? Well, it's the number that you multiply each time, and it's 1/3. So you basically have 36 times 1/3 to the 5th. Please do not multiply 36 and 1/3. Say this is 12 to the 5th. Only the 1/3 is being raised to the 5th power. If you knew your powers of 3, like I asked you to last year, you should know your powers of 3 up to 5.
It's 243.
It's 243. And if you notice, 243 and 36 are divisible by what number? 9. Okay? So this would have been 4. And then,
Yeah.
So 4 or you could divide by 3. You could divide by 3 like 3 times.
yeah. So that's what I'm going to do. Because I'm like, oh, 9.
I didn't want to talk about 81.
Here's the next one. Find the second term of the sequence. Find the second term of the sequence.
9 times 4 is supposedly 54 in my mind. So that's where 9 times 4 is 54. Yeah, that's what my work
10 times 4 isn't even near that.
I know.
I mean, well, I mean, it's 14.
What was your first term? 2.1?
I didn't figure out my first
I
one.
mean, if you want to do it the hard way,
No, wait.
Yeah, I mean,
That
it's a
was a
longer
different
way. I just haven't done it because
It's a way that allows you to get some marks.
I don't need no sticky
We're
mark
not
points.
getting
I just
right.
get everything right.
Yeah, but then what if it's a problem where they don't award you the full 6 points?
I'll get some wrong.
I mean, I just,
It'll be
just
enough
made
to
the
get
second
an
term
85.
and the first term, and the term we were given.
Yeah. So then I did 9, 56.
That works. That works. Push everything back. That works. All right, here we go. Which term of the sequence is equal to 75?
Why?
Oh no, we're gonna spend so much of our time on names on the board because we all pass it.
Now this one, since you were looking for M, another way, which is the way that I think you guys did the other problem.
Divide by 4.
Divide by 4. This is another way. And then you get what, 18? So N is 19. Here's the next one. Find the sum of the first 6 terms of the series. What's your answer?
Hold on, I'm almost there. I tried non-calculator and I'm almost
My
there.
answer is more exact.
Is this, alright, bring it back. Is this geometric or arithmetic?
It's still there.
It's geometric. It's geometric, okay? And remember, you can always determine if something is geometric by taking the second term and dividing it by the first term and it equaling the third term divided by the second term. Okay, you guys remember doing that? That's also how you can show that something is geometric. Okay? So like you can do this, type this into your calculator, making sure you have the parentheses around it. And it should equal the same thing, telling you your ratio. What was our ratio? 3/5. Okay? So again, that's how you show something's geometric. And that's also how you can figure it out if you don't know it. And then to find the sum, the formula is your first term, your ratio minus 1, all over your ratio minus 1. So 3/4. 3/5 to the 6.
It's a process.
Make sure that you do this in your calculator, guys, and you try to do it all in one line. Please make sure you include parentheses around that. What was your numerator?
5, 8, 6.
And your denominator?
3, 1, 2, 5. Hold on, so close.
And that would have been, what as a decimal?
1.79.
So either one would have been acceptable. Clear your boards.
I did it via arithmetic, but it
I remember Austin before saying that.
So
Down.
That's
Still
your calculator?
Alright.
Oh.
Okay, bring it back. Determine the following sequence is convergent or divergent.
Oh.
Not yet.
What made you guys say it that way?
Why did you make it say it that way?
You know what? I think I should have die. It seemed like getting small like
Yeah,
dividing, so I should have went with that one probably.
Okay, so I did this because divergent as in it's getting farther away from the one, so it's like an thing, so it's diverting from the x-axis, and I did converging for 16 because it's getting closer to the x-axis as it gets smaller.
That is correct.
Oh my God.
That's a good way to look at it. And I mean, and think like, if you ever did see that movie Divergent, she was like above all the others, like her skill, her ability, and that's true. This one here was divergent. This one here was convergent. Convergent basically means that it's approaching a particular number. Okay? So basically, if I did ask you to find the sum of these numbers, like this one is going to start getting really, really close to one solid number because these numbers are going to continue to get smaller and smaller. This one, the numbers are going to keep getting bigger and bigger, so this one's going to approach infinity the more sums you start to add. And another way you can tell is looking at the ratio. What's the ratio of this one? 3. What's the ratio of this one? 0.5. So convergent series are ones where the ratio is less than 1.
8 divided by 2 is 4.
Not 2.
No.
But 2 divided by 4 is
Not
not
1, so that's not the ratio either.
I know, I couldn't figure that out.
Well, that is true. Okay, so that was.
Because it wasn't even in a.
It should have been.
I don't even know what the ratio is.
It's not important.
Well,
It's just
regardless, okay, that is one way that you can look at, okay, because the numbers are getting smaller, you are converging to a particular number, okay. Another way you can look at it is look at the ratio. Now, yes, the ratio here is not 1/4, but convergent series will have a ratio that's in between 0 and 1, and divergent series will have a ratio that's bigger than 1, okay. Everybody got that?
So would the third term be 1/6?
Okay.
I mean, not 1/6.
I found the ratio. 1/2 root 2.
All right. Same topic, but switching gears a little bit. Let's see who remembers this. All right. With these guys, you are forgetting this notation. This right here means combinations. This deals with your Pascal's triangle. The notation summation is this. Okay? It can also be written like this.
I got it right. I did it.
That is not calculated.
Oh.
Yes.
Is it really fun?
The formula is n factorial all over r factorial n minus r factorial.
So hey, I was
So
told
NCR is this. That's what's in your reference booklet. If you had to figure this out by hand, which is very possible, the factorial means you multiply. Start with the number and you go down. R factorial, 4 times 3 times 2 times 1. 6 minus 4 is 2. Do the factorial there.
Cross out.
Cross out things that are in common. So you have 30 over 2, which is 15.
Or you do 6 4, 5, 5 times 3. But 3 must be 3. 3 is divisible too. So 6, I mean.
This is also looking at the 6th row of your Pascal's triangle. Not saying that I will want any of you guys to do this, because one is going to be very time consuming, especially if it asks you for the rows particularly like 9 or something like that. So basically NCR, N tells you what row you're in of your Pascal's triangle, and R tells you the spot. But remember with Pascal's triangle, just like with binomial expansion, there is a 0 power. So this right here is in the 0 position. This is the first one. This is the second one. This is the third one. This is the fourth one. Okay? So when you do something like this is basically 6 over 4. Okay? So you're looking not at the fourth number in the row, but basically holding in that fourth spot. There is a 0 that you start with, 5th, and then 6th. You guys remember that?
Yes.
Okay, good. All right, now let's give it a try. We'll give you another one, okay? Here we go.
Non-count.
Non-count.
Yes.
You were close.
1.
3, 1,
Oh.
8, 2, 4. You would have gotten to this point.
I got half of the ring, so I forgot to
Screw you.
I was you.
In all honesty, I'll probably try to take out the bigger numbers to make these a little easier. So 6.
3, and you give it 18.
Alright, I would have also have gotten 7 and 2 to get rid of 14. I would have divided this to get 3 and this to get 4. So in that way I would have had 17 times 13 times 144. That is what I mean.
Yeah, I got 18 times 17 times 16. This is I did it harder than that.
No, I think
So I took that's what I.
And then you kind of multiply.
I got 17 times.
But something like this, I want you guys to do it by hand just to refresh your memory on it. It can be done by calculator. Honestly, something that large would definitely be a calculator. You type in your first number, then you go to math. You go over to PRB, and there's NCR. And like for my calculator, it automatically takes me into the notation that I want. But for you, it might just be this, and then the NCR. You type in 7, and then you click enter, and there's your number. Okay. We only deal with NCR, not NPR. Okay?
By 13.
All right. So, staying around, oh no. Summation. What does this mean?
That's the explicit form, right?
This is the explicit form.
5 terms. So if you're looking for the sum of 5 terms,
You're looking for the sum?
and you can just plug 5 in there, 4 in there, 3 in there, 2 in there, 1 in there, and you have them all in.
Exactly. You plug in 1, plug in 2, plug in 3, plug in 4, plug in 5 into the formula. What's 1 times 5 minus 1?
4. 9.
9.
14. 19.
Notice a pattern.
Yes.
This is the explicit form for what type of a sequence?
Arithmetic.
Arithmetic, where the common ratio is, common difference is 5.
So n equals the first one.
So no, remember this is the explicit form. So this is always your common difference. then you just add them up. This right here is 13. 13 plus 14 is 27. 27 plus 19 is 46. Plus 24 is 70. Okay? Got one for you to do. Clear your board. Do this one. Find my sum. This one is 11. You plug in 1. You plug in 2. And you plug in 3. You add them up. Okay? Honestly, when you're dealing with summations, that is the easiest route to go. Okay? Plug in those values and add them up. Okay? The number at the bottom tells you where to start. It won't always be 1. It might be a different number, but this is definitely where you end. So it goes from bottom to top. Okay? Last little bit. Expansions. Okay? Remember, this is where you apply your rules that deal with binomial expansion. Now, this is a small one. This one's going to be pretty simple, okay? But there's a couple of things that you need to remember. There was actually, I believe it was 5 things that are true when you're dealing with an expansion, okay? Your first variable, okay, so in this case, x, your first variable is going to decrease. Its exponent is going to decrease while the second variable does what? It's going to increase. Okay, these are ways to double check to make sure that you didn't like mess anything up, okay? Your number of terms is always what? Does anybody remember? When you expand this, your number of terms is
One more than the power.
Is always 1 more than the power. All right. The coefficients are always from your Pascal's triangle. Or you can think of it from your binomial theorem. Okay, remember it always goes 3, 0, 3, 1, 3, 2, all the way up to 3, 3. That's what the binomial theorem tells you. Okay? And the last thing is that each term, the exponents should add up to equal your power. Okay? So, when we try to expand this binomial, okay, the first variable is going to decrease, so that's going to be 3, 2, 1, all the way down to the 0 power. Your second variable is going to increase. Now, because it's a negative, that minus is going to go with the y. It's going to be a negative y to the 0 power, negative y to the first power, negative y to the second power, and negative y to the third power. Don't forget about the negatives. Now, there's a reason why I put this in parentheses, because I don't want to forget about the negative when I'm raising it. If there was a coefficient, the coefficient is also being raised to whatever power or the variable is being raised to. And if you notice, 0 and 3, 1 and 2, 1 and 2, 0 and 3, they all add up to be 3. And then your coefficients, Pascal's triangle says 1, 3, 3, and 1. So my answer is x to the third minus 3x squared y plus 3xy squared minus y cubed. If it is a minus in the original binomial, the sign is going to rotate, alternate. Okay? So I want to give you guys one to try. All right? Here we go. And I'm going to time you. Yes. Giving you 6 minutes.
Once you be like to the 9th power, you're close. 30.
30x minus 50 y, power 28.
Here we go. Ooh. 6 minutes. So here we go. You had to expand this. It was the 4th term, so I should have how many terms should we have?
5.
5. Count your terms. You have 5 terms?
Yeah.
Do your R coefficients decrease?
One of our answers is
row. I need my first variable and coefficient to decrease, while my second one does what? Increases, starting at 0. So then anything to 0 power goes away, so I'm just left with 16r to the 4. Are we starting out okay?
Yes.
All right. This one I'm going to have 4 times 8r cubed times a negative 4s. So that's basically 32 times 4, which is a negative 128 r to the third s. Okay. This one's going to be 6 times 4r times negative 16s. Sorry, you're right, positive 16s. So that is
384.
And I forgot my exponents, I apologize. R squared, S squared, so far so good? This is 4 times 2R times 64 S cubed.
Negative 512 RS.
Negative 512,
Yes.
RS cubed. And then the last one, this goes away. And this is going to be a positive 256 S4.
That's 4, that's what I meant.
And so there's your expansion. 16r to the 4th minus 128r cubed s. 384r squared s squared minus 512r s cubed and 256.
Job, Anna.
I couldn't add 3 plus.
She's sitting there like, I need a calculator.
Now,
Yeah.
bring it back. Now, sometimes they might ask you to find a particular term within the expansion, so you don't have to do the whole thing. But it's okay. It's actually fairly easy to do this. Honestly, it's a lot simpler. Now, look at the power. More than likely, it's probably a calculator type problem, so you won't be doing like too many ridiculous numbers. But if I'm looking for the 6th term in this order, it's going to be a lot easier to use the binomial theorem notation. Okay? Remember, you have your first variable, your second variable. They're going to be raised to some exponent. And I need to fill out this part as well. What number goes at the top? 12. And if I'm looking for the 6th term, it's 5. Because remember, we start at 0, 2, 3, 4, 5. So this is actually the 6th term. What goes here?
6. That's 5.
7.
It could be 5 or it could be a 7. Okay? All right, but in all honesty, this one actually should be the other way around.
7, 5, okay.
It should be 7 and then 5, because if this is my 5th term, remember the first variable is decreasing. So this starts at 12 to the 11th to the 10th to the 9th to the 8th to the 7th power for that variable. And then we just plug it in. So you guys do this in your calculator. What's 12 combination 5? What number is that? Yeah, this is definitely a calculator. What's 2 to the 7th power?
128.
It's be 128 n to the 7th and then m to the 5th. So the last thing you have to do is multiply 792 and 128 to get your 6th term. N to the 7th, m to the 5th. And that's how you find just one term out of the sequence. You guys remember doing this?
Yeah.
Sometimes it'll tell you, instead of saying, for the particular term, they might ask you for what's the m to the 7th, m to the 5th term. They might ask you for that instead. Or they might ask you what's the coefficient of that term. They ask you for the coefficient, they just want that front number. Try this one on your own. Calculator.
Oh, the 4. Oh, yeah.
9 should have been the top, and if you're looking for the 4th term, that means it should be combination 3. And because, remember, your first coefficient is counting down, this one should have been the 6, and this one here should have been the 3. So this would have been 84 times 8 to the 6 times a negative 8, and you should have got a negative 672. What? If you're counting up, it shouldn't, like the first exponent should never count up, it should always go down. And the second one should always go up. Now there will be a time where the number, the first variable one would be smaller, it just depends if you're further down in the terms. Like if it asks you for the 8th term instead, then this would have been the small number, this would be larger. But no matter what, they need to add up to equal 9, and then this number needs to match. Okay? Alright, so that's patterns.